Second law of efficiency. This term refers to comparison of the desired output of a process with the cost or input in terms of thermodynamic availability. Thus, the isentropic turbine efficiency, for example, as the actual output divided by the work by the height for a turbine, the actual work on Ws. Output divided the work by the hypothetical isentropic expansion from the same inlet state to the same exit pressure will be called the first law efficiency. As just described, would be the actual work output of the turbine divided the decrease in availability. For the second law, efficiency, we have this actual work output of turbine divided by the decreasing in availability availability from the same inlet state to the same exit state. For the turbine showing in the, for example, this sketch, the second law efficiency In this sense, these concepts provide a rating or measure of the real process in terms of the actual change of states. In simplify, another convenient way of utilizing the concept of thermodynamics availability. In a similar manner, the second law efficiency of a pump or compressor is the ratio of the increasing in availability to work to the device. It is for turbine and for pump and for the device that does not involve the production of input of work. The production or the input of work. The definition of second law efficiency refers to the accomplishment of the goal of the process relative to the process input in terms of availability, change, or transfer. The definition of second law efficiency refers to the accomplishment of the goal refers to the accomplishment of the goal of the process relative to the process input in terms of availability, change, or transfer. For example, in a heat exchanger as this picture, we have high temperature flow low temperature flow. The second law efficiency is defined as heat exchanger F.1 the previous expression for the second law efficiency can be presented by a single expression. First, notice that actual work from the relation actual work minus I dot, in this case the W reversible equals to P source V dot source set minus irreversibility of the system. In this equation, V source is the total rate of availability supplied for all sources. Total rate of availability supplied from all sources flows heat transfer and work input. Flows heat transfer and work input. In other words, the ongoing availability dot control volume equals to the incoming availability less the irreversibility. Incoming availability minus irreversibility. Then for all cases we may write the second wanted on feed source and feed dot source minus irreversibility on feed dot source. For all cases, it depends on the type of the irreversibility and availability in the system. And the wanted quantity is expressed as availability, whether it is actually a work term or a heat transfer. We can verify that is covered the turbine equation, pump, compressor, heat exchanger efficiency also. The next section is exergy balance equation in the next video part.